So, fill in the blanks made it easy for you. Quickly, the included side here, if we had two angles, the side that would be between the two angles would be what's known as the included side. So, what I have to do there is just put the appropriate arrows. And our angle side angle postulate states the following. If two angles and an included side of one triangle are congruent to two angles and an included side of a second triangle, then the triangles are congruent. So if we look down here on these triangles, if I have this angle congruent to this angle, and this angle congruent to this angle, where would the side need to be included or in between? Left, top, or right? Left, right. So that would be your included side. So sometimes it helps put it. This is an angle, so I'm going to put an A there. This is a side. This is an angle. Angle, side, angle. Okay. So if we look at the two examples below it,
oh, I didn't finish filling it in.
well, you need to be quicker.
I just had two left.
I don't think it's saved anymore. 2 ways for what?
2 ways, oh, yeah.
Thank you, Ashley. All right. So, determine whether the triangles are congruent or not. So, here I have an angle, angle B, so I'm going to put an A there. Here I have a side, I'm going to put an S there. Here I have an angle, so I'm going to put an A there. Let's make sure it works on the other side. Angle, side, angle. So, do I have A, S, A?
Yeah.
Yeah, so I'm going to say yes by A, S, A congruence. Let's write a triangle congruent statement. Triangle, if I go A, B, C, what would be the matchup on the other side?
M, N, L.
Perfect. N, M, L. So if we look at part B, do we have two sets of congruent angles?
I keep writing the triangle as an A.
So here we have an angle. Here we have a side. Here we have an angle. Here we have a side. Do I have another angle?
Vertical.
Vertical angles. We can always assume vertical angles are congruent. And if you are given parallel lines, then you can assume alternate interior angles are congruent. So here we have another case of angle, side, angle. So I'm going to say yes by angle, side, angle congruence. Triangle, I'm going to go M, N, T. If I go M, what corresponds to M on the other side? A. N corresponds with D and then T. Good.
Yay.
So, angle, side, angle. The side needs to be between the two angles. For angle, angle, side, the side is not going to be between the two angles. So let's go ahead and fill out this theorem. So if two angles and the non-included side of one triangle are congruent to two angles and the non-included side of a second triangle, then the triangles are congruent. So, if I choose this top angle congruent with this top angle, and bottom right congruent to bottom right, where would a non-included side be? Left, bottom, or right?
Left.
Left would work. Why would bottom also work? Yeah, that's not an included side. So really you have two options for which one it could be. We'll just go with the left because that's what I heard first. Okay, so if we look on the back two examples, it's the only two that we're going to do. We'll say proofs for tomorrow. Do I have two sets of congruent corresponding angles? Yes. Oops, I'm writing in highlighter. Here's an angle, here's an angle. Here's an angle, here's an angle. Where is the side? The reflexive property. You should always be able to recognize that reflexive property. Is that side in between the two angles? No. So that's why this would be a case of angle, angle, side. And if I go triangle CAB, that would be...
No.
Nope, it is, because we have an angle, angle, side. That's what that theorem says. And C would correspond with B on the other side, A corresponds to D, and then C. We look at part B. Do you have two sets of congruent corresponding angles? Yes, there's your angle, there's your angle. Where's your side? In the middle with the reflexive property. Is the side in between the two angles? Nope, so yes, phi, angle, angle, side, congruence. I'm going to go triangle NLM would be congruent to triangle MON. And that is that. So we'll say proofs